Hey guys, in this video we would do stoichiometric calculations, and the example that we are going to use is to create the amount of grams of a compound in the product from the given grams in the reactant. As we all know, stoichiometry is that part of chemistry that helps us calculate the quantities of chemical elements or compounds that are present in the chemical reaction. So we would be using stoichiometry for this particular calculation. Let's take up an easy example to understand this type of stoichiometric calculation. The question is, how many grams of ammonia is formed when 3 grams of nitrogen and 4 grams of hydrogen react? Now first let's convert this into an equation. Because nitrogen is reacting with hydrogen, so nitrogen and hydrogen will form the reactants and the product is going to be ammonia. We know ammonia is NH3. So remember, even if this nitrogen and oxygen was not given in this molecular form, if it was given in the word form, still we would put it as N2 and H2 because N and H belong to Hofbrinkel category, and any Hofbrinkel atom is going to be placed in a reaction in the form of a diatomic molecule. Diatomic means 2 as a subscript to that atom. Now we look at the question, and the question wants us to find us the quantity. How many grams means the quantity of the product when the quantities of the reactants are given. So basically we are given quantities of reactants and required is the quantity of the product. And we know whenever we need to use quantities to find quantity in a reaction, we would have to use stoichiometry for that. We have to remember this one thing here is that for solving any stoichiometric problem, there are just 4 steps to follow. And these 4 steps will always come handy in stoichiometric problems. The first step is to balance the equation. Second step is to convert the given quantities to moles. If the given quantities are already in moles, then we can skip the second step. Third step is to use mole ratio to find the mole of our unknown compound. Fourth step is to change the moles of unknown compound to the required quantity. So these 4 steps make our life easier when we need to do stoichiometric problems. Let's apply these 4 steps in the given question. Now going back to the question, we see that we are given 3 grams of nitrogen and we are given 4 grams of hydrogen. So let's rewrite it. We're given nitrogen and oxygen that give us ammonia. Our first step is to balance the equation. So we would balance the equation. Left side has 2 nitrogen, right side has 1 nitrogen. I want to make this nitrogen 2. So I put 2 in front of the compound. This makes my hydrogen 2 times 3 is 6. And I put 3 here in order to get 3 hydrogens on the left side as well. And I got my equation in the balanced form. Next thing is I am given is my mass. So whenever we are doing stoichiometric problems, it's always best to make it into a clarified table form. The first thing that we are going to put in is the mass. That is our given quantity. We're given mass of nitrogen to be 3 grams and we're given mass of hydrogen to be 4 grams. And the required quantity is the mass of ammonia. So we'll put X grams here. Once we have written our given in the table form, we'll do the second step, and the second step is to convert all the quantities into moles. So converting all the quantities to moles, and we know when we have to convert mass to moles, we have to do given mass over molar mass. That would give us the number of moles. So first we would find out the molar mass. This uppercase M stands for molar mass, and we can get the molar mass from our periodic table. One thing we have to remember before finding the molar mass is that the small subscript is part of the compound's name. Therefore, when we are finding the molar mass, it's not just the one element that we'll pick from the periodic table. We also have to take this number into account. Nitrogen mass is 14.01 grams per mole. N2 mass is going to be 28.02 grams because it's 14.01 times 2. So we'll put this molar mass under nitrogen, and that is 28.02 grams per mole. Next we find out the molar mass of hydrogen. So we're not going to take this number 3 into account because this number is just used for balancing the equation. This is not part of the formula. So molar mass of hydrogen is 1.01 on the periodic table. Therefore for H2 molar mass is going to be 2.02 grams per mole. We can also find out the molar mass of ammonia, and that is equal to 17.04 grams per mole of ammonia. Next thing we have to do is we have not yet completed second step, and second step is conversion to moles. So to convert to moles, we would have to use both the mass and the molar mass. That's the reason we found out molar mass. We know number of moles is equal to given mass over molar mass. Given mass is this, divided by 28.02, and that gives us 0.107 moles. Similarly, we'll find the number of moles of hydrogen, and that is going to be 4 divided by 2.02, which is equal to 1.98 moles. So we're done with the second step, that is converting the given quantities to moles, and we've already converted the given quantities, that is 3 gram nitrogen to 0.107 moles, and 4 grams hydrogen has been converted to 1.98 moles. We'll move on to step 3, and step 3 says that we have to use mole ratio to find the moles of the unknown compound, and our unknown compound is ammonia. So we want to find out the moles of ammonia. This we have to find out, but we cannot find out the moles of ammonia using the same method as we did for nitrogen and hydrogen, as we're not given the mass of ammonia. So we would be using the mole ratio to find out the moles of ammonia. Now, what do you mean by mole ratio? Mole ratio means we would use one of these two given reactants to find out the moles of this product. But here, we cannot use any one of the reactants. The only reactant that would help us to find the moles of ammonia is the limiting reagent reactant. So in this particular question, this is something extra to the stoichiometric steps, and then that is to find out the limiting reagent reactant. Now, what is a limiting reagent? Limiting reagent is the reagent that gets consumed the first in a reaction. So we would be doing limiting reagent calculation. Limiting reagent calculation is very easy. We would take the moles that we have obtained for each reactant, divided by the number of moles of that particular reactant in the reaction, and that would give us 0.107 divided by 1 is nothing but 0.107. Similarly, we'll do the limiting reagent calculation for hydrogen, and we would do 1.98 divided by this number, and the number that we get is 0.66. Now all we have to do is just compare limiting reagent calculated moles, and we got 0.107 for nitrogen and 0.66 for hydrogen. The smaller number is going to be the limiting reagent. So our limiting reagent is nitrogen. So we would be using the moles of nitrogen obtained to find out the moles of ammonia, and we would discard the moles of hydrogen, because nitrogen are the moles that are going to be consumed first in the reaction. So the amount of nitrogen is going to decide how much amount of ammonia is going to be formed. Now to do that, we would do molar ratio calculations. For doing molar ratio calculations, all we have to do is just take the unknown moles divided by the known moles. Let's call these unknown moles N. So we would put unknown as N. Known moles that we obtained was 0.107, and we are using the moles of nitrogen, not the hydrogen, because nitrogen is the limiting reagent. And we put this ratio equal to the ratio of the balancing numbers. And the balancing numbers we have is 2 for ammonia, 1 for nitrogen. In the same form, unknown over known form, 2 for ammonia over 1 for nitrogen. So technically we have N moles of ammonia, that's what we are looking for, divided by 0.107 moles of nitrogen is equal to 2 moles of ammonia divided by 1 mole of nitrogen. So we're using this ratio proportion technique in order to find out the unknown moles, that is N. And then all we have to do is just isolate N moles of ammonia is equal to 2 multiplied by 0.107 divided by 1, and that gives us 0.214. So the number of moles that we have got here is 0.214 moles. And we completed the third step, where we have to use mole ratio to find the moles of unknown. Our fourth step was to find quantity of our desired compound. Our desired compound is ammonia, and we are looking to find the mass of ammonia. Mass is X. To find out mass of ammonia, all we have to do is number of moles of ammonia multiplied by the molar mass of ammonia, and that would give us 10.067 grams of ammonia. We always have to remember that the moles is equal to mass divided by molar mass. Moles is given as lowercase n, mass is given as lowercase m, and molar mass is given as uppercase M. This can be filled up into this triangle where here goes the mole, here goes the mass, and here goes the molar mass. So if you're looking for moles, we'll be doing mass over molar mass. If you're looking for mass, we'll be doing moles multiplied by molar mass. Let's quickly summarize the problem. We were given 3 grams of nitrogen and 4 grams of hydrogen, and we were supposed to find out the mass of ammonia. Our first step is to balance the reaction. We write on the reaction and we balance the reaction. The next step is to convert the given quantities into moles. We were given mass of nitrogen and mass of hydrogen. We converted that to moles. To change mass to moles, we have to divide with the respective molar masses. So we find out the molar mass of nitrogen and molar mass of hydrogen. Once we get the number of moles, because we are given the moles for both the reactants, now to use the molar ratio, we need to decide which reactant to be used. And the only reactant that we'll be using is the limiting reagent reactant. So we'll do the limiting reagent reactant calculation. In order to do that, all we have to do is just take the moles that we obtain for each reactant and divide it by the number that is used to balance the reaction. Because for nitrogen there was no number, so we put 1. We divide the number of moles of nitrogen by 1 and we obtain this. For hydrogen the number was 3, so we do 1.9 and divided by 3 and we obtained this. When we compare the two numbers, this 0.107 is smaller than 0.66. So we conclude from here that our nitrogen is limiting reagent. Now if the nitrogen is limiting reagent, hydrogen has no job to do further. We'll use nitrogen to find out the number of moles of ammonia by using molar ratio. This is how we do molar ratio calculations. We do unknown over known. Our unknown is ammonia, known is nitrogen. We are looking for n moles of ammonia if we are given 0.107 moles of nitrogen. And this ratio comes from the balancing numbers of the reaction. We have 2 ammonia and we have 1 nitrogen. Then we are looking for this n. All we have to do is just cross multiply and we'll get the number of moles of ammonia. The number of moles of ammonia we obtained was 0.214. To get the mass x, we would be doing moles multiplied by molar mass, and that would give us the mass of ammonia. This process is not long. What we did was we just converted mass of nitrogen to moles of nitrogen and mass of hydrogen to moles of hydrogen. We used both nitrogen moles and hydrogen moles to find out the limiting reagent, and we figured out that nitrogen is the limiting reagent. We used the limiting reagent moles to find the moles of ammonia. So once we got the moles of ammonia, we converted it back to mass of ammonia. So this is all what we did in this particular problem.